Welcome to MEI Modelling with Algorithms. We're on the topic of critical path analysis, and this is video 1.3, Analysing an Activity Network. Now, there are lots of things that we can find out by analysing an activity network. In this video, we're just going to concentrate on the basics. So we've got what's called the forward pass, and what that, as you'll see, allows us to do is find the earliest event time for each event and the minimum completion time for the project. And then after that we can do what's called a backward pass, and that will tell us the latest event time for each event. Now, in order to carry out a forward pass, and indeed the backward pass that comes later, what we'll do is, instead of having those little circles, numbered circles that we had earlier to represent the events, we're going to represent the events with double boxes, and eventually we're going to have two numbers in these boxes. To start with, we'll just be entering the first number, the number on the left. Those are the numbers which are going to tell us the earliest time at which activities can start. And all we do is we start by saying that the first event here, obviously that's when the thing starts, so that will always start at time 0. And then we look at activities which follow on from that event. Activity A here has a time of 6, so that means that when we get to this event, the earliest this event can occur is time 6. Similarly, this one is time 4. It's tempting to look at this one and put a 15 in over here, but actually we can't do that because this event depends on these other two activities and we don't know anything about these yet, so it could be that these can't actually start until later, and so potentially this number might have to be larger, so we'll leave it for now. We can certainly deal with these two boxes though. This has an earliest time of 6, so this one happens 10 seconds or 10 units of time afterwards, so that must have an earliest event time of 16. This will have an earliest event time of 17, just adding the 13 onto the 4 there. And then over here, well, we've got three things which all have to happen. And this can't occur until all three have happened. So we're actually looking for the latest of these three times. So 16 add 4 would be 20, 17 add 2 would be 19, or 15 by itself. Alright, so the largest of those is the one that we actually have to say, which is 20. And that's the forward pass complete. I think it is definitely worth saying here, this sometimes when you're doing this, it feels a little bit like you're doing Dijkstra's algorithm, and you're really not. The big difference is in Dijkstra's, you're only ever choosing one path through, and so you're looking for the path through a network which has the shortest weight. In an activity network, all of these things are happening. Okay, so we can't say anything about this. This event can't take place until everything else that leads to it has happened. So this really is not anything like Dijkstra's algorithm in the end. And what we can conclude from having done this is that this project has a minimum completion time of 20 units, and it would be impossible to do it in less time than that. So the next thing we're going to do is what's called a backward pass, and what the backward pass will tell us is the latest time at which each activity can finish. So when we carry out the backward pass, as you might have guessed, we start with the end node, and in here we can say that the latest time that this activity will, this event will occur, will be 20. So that will always be the same number, because if it was any later, then obviously we'd have time that had been wasted. So this has to finish at 20 units. Then what we do is we look at any nodes which directly precede this one, and look at the time that would have to start by in order to realize this latest time here. So for this one actually, this has this activity takes 4 seconds, so this would have to finish at 16. Activity D would have to finish at a time of 16 in order for activity F to start and reach this latest time of 20. Here though, activity E, even though it can start as early as 17, it could actually start as late as 18 without delaying the whole project, because G only takes 2 seconds. So as long as we get to this event by 18 seconds, then we can complete by 20. I'm not going to look at this activity yet at the bottom, taking us to the start, because similar to what happened when we did the forward pass, there are other activities which are going to affect this one that we might need to consider. So let's go here. This has to finish by 16. This activity is taking 10 seconds, so subtract that to get 6. Here though, we don't actually need to finish this until 18. It takes 13 seconds. 18 take away 13 is 5. So we do have a later latest finish time for this than the earliest start time. And then this start node, well actually you can reason it both in several ways, but certainly this one tells us that it has to it has to have a latest time of 0, but actually, as you may well have guessed, for this for the first event, it's always going to have a latest finish time of 0, because otherwise you'd have to be delaying the start of the project. So that's the forward and backward passes completed. We can pick out just a couple of things that we can now conclude from this. What you'll notice, and this usually happens, is that some of these events we have the same number for both. So there's no sort of freedom there in that sense. But other ones do have some leeway. And what we're going to talk about in later videos is exactly what that means. There's a idea of what's called float, which is a bit of sort of free time, a bit of flexibility for certain activities in terms of when they might start and end. And also the idea of what's called a critical path. There's a particular route through the activity network that will actually minimize the time, and all of the activities along that critical path really do have to start bang on time. There's no leeway for those ones. But as I say, that will be the subject of a later video. So that concludes video 1.3, analysing activity network. The next video will be 1.4, finding critical activities and critical paths.